Welcome to our latest Tech Forward webinar. Today we will talk about switching from monolith to microservice architecture and various things that we need to consider when making that decision. Hi, my name is Ilya. I'm senior software developer with a tech lead role. I have 10 years of experience in IT and I'm a proud member of HTEC for almost 3 years. In today's presentation, I will also be joined by my colleagues Zoran Vukosavljev, who is a solution architect, and Milan Ličanin, technical delivery lead. Milan contributed to this presentation with his experience and he will join us in a Q&A session. Also, we will have another solution architect, Slobodan Boljanović, who will join us as moderator for QA part. In the first part of presentation, I will speak about microservice advantages and disadvantages and go through several approaches in the migration process step by step. Then Zoran will focus on the business value of switching to microservices and some aspects of the client relationships. On the left picture, we can see the diagram of monolith application where we have all functionalities in one application. On the right picture, we can see an application that is divided into microservices, which are following the pattern database per services and the user interface, which is also separated from the main application. Microservices are not always the best solution. They have both advantages and disadvantages, so we need to choose wisely depending on the project needs. We must take into consideration both short and long-term goals. Monolith is not necessarily a bad thing. Good modular monolith is often good enough and ready for easy transition. The overall cost of switching is usually high: human resources, money and time. Solution architecture is about making technical decisions which are expensive to change. Crucial is that all stakeholders should have common understanding of monolith versus microservices. Valid reasons for switching to microservices are long-term agility, improving scalability, speeding up the pace of change. There are plenty of advantages of microservice architecture. Some of those are: development teams can be more autonomous, faster release cycle since changes could be deployed without affecting other microservices. All the microservices can be deployed and updated independently, which gives more flexibility. Every service could be scaled independently based on needs. We can reduce downtime through fault isolation. And failure in one microservice has an impact only on particular service and does not influence the entire system. Microservices are following single responsibility pattern, and we can reuse code between microservices and develop them in any different languages. There are also disadvantages that come with microservices. There is additional complexity of distributed system. Distributed transactions can also become very complex. There is a chance of failure in communication between microservices. There can also be issue with interface control. Sometimes it is difficult to manage large number of services when the system is complex. There is an additional network latency and load balancing. More team collaboration is needed. Testing the overall system is more complex, and the same goes for debugging. The fact that system is divided into smaller independent components, microservices, implies that these components can scale completely independently from one another. On the diagram, we can see that microservice A has 3 running instances, C has 2, and B has only 1. So, for instance, if our application goes viral, we can scale up the microservices that have the highest load and not everything else. We can even remove the human factor through tools that allow business metrics and analytics data from the production environment to actually trigger scaling operation automatically without having any human intervention. For example, we can set metrics to measure every CPU load for all instances, and if it reaches the threshold and keeps it for specified time, for example 1 minute, we can then automatically scale up or scale down. When one service fails, how does that impact the collaborators and ultimately the applications and customers? On the diagram, we can see the reliability of one microservice depending on collaborators. We need to design and build our services to maximize availability and recovery when failure occurs. There are several techniques for ensuring that services behave appropriately when their collaborators are unavailable. These techniques are retries, fallbacks, caching, timeouts and deadlines, circuit breakers, and communication brokers. Now let's consider how we can maximize availability and fault tolerance within an individual service. There are few techniques to achieve this, such as health checks, rate limits, and methods for validating the resilience of services by load testing and chaos testing. It is possible to deploy only one microservice while others continue to run, unlike the Monolith application, in which we have a large box that requires the deployment of all services to deploy the application. In order to allow teams to continually deliver, a set of processes and practices known as continuous delivery has been defined. This does not mean that everything is deployed into production every time something gets changed. It means that every change is proven to be deployable at any point in time. Tools like Jenkins and many other incorporate those ideas and offers a solid base for a development team to achieve maximum agility. Some popular deployment strategies are blue-green, rolling, and canary. On the left picture, we can see 3 microservices where we are deploying new version of microservice C. Once microservice C is deployed and health checks are passing, then we can route traffic to the new microservice and delete the old one. One of the best things about microservices is ease of testing. Since developers are focused on one part of the system when upgrading, you can easily test a small part of the system before releasing it. Maintaining quality is crucial for any business, and to support this development speed, the job gets infinitely harder. This is exactly where microservices excel. Since the size of each service should be smaller than the full monolith, to fully test and achieve very high coverage with automated testing is very feasible. It is in this scenario that the practice of continuous integration ensures that a very high quality is maintained in our deliverables at any point in time through automated testing and deployment pipelines. However, there are some other serious issues that needs to be addressed, because it is true that microservices are independent, but they do cooperate. A bad change can cause what is well known as cascading failure situation. Contract-based testing is an example of how to catch this situation early in the development process and avoid failure in production. Distributed systems are not simple, and microservices are no exception. If not correctly addressed, this architecture will definitely bring huge pains. The task to discover whether there is an issue or not on the system is absolutely not trivial anymore. It is just not possible to manually analyze the logs from all these services. We should think about solutions to centralize logging and monitoring so that our application teams and feature teams can have an overview of the system they are responsible for. There are two popular ways of transforming from monolithic to microservices. Creating a next generation project that is based on microservices or using the strangle pattern. First way is by creating a completely new next generation project. We could learn from previous mistakes and resolve them by introducing new architecture that support microservices. All generation project would be supported in parallel since it is in production and there are customers using our application. This way is more costly and requires more time until production. Other way is to use strangler pattern, which means that all new functionalities would be written in new microservices. Old functionalities are separated one by one into microservices. This way is less costly and faster to production since we only have one application to maintain. On the other hand, it is harder to resolve previous architectural issues. On this slide, we will mention main steps in the strangler pattern. First, we need to divide the application into domains, feature or modules. Secondly, database should be split per module, and then we will separate one by one module to microservices. And lastly, route traffic with API gateway to new microservice. For communication between microservices, we should tend to use asynchronous communication if possible, using message brokers. As with any project related to architectural changes, the transition from monolith to microservices requires thoughtful and careful planning. Depending on the chosen strategy, the transition could be done in few ways. On this example, we use domain-driven design to achieve the transition. These would be the steps in the process, which will be explained in more details in next few slides. Monitoring and measuring the load on monolith application, adding a gateway in front of application, dividing the application into modules, adding a message broker, transforming modules into separate applications, dividing data storage. This is the initial state of monolith application. First, we need to add monitoring and logging, and then we need to measure load. Second diagram introduces another layer, the API gateway, that sits between the client application and application logic. The API gateway is a facade layer that provides a consistent and uniform interface for the client apps to interact with, while allowing downstream services to evolve independently without affecting the application. Monolith app is placed into private network and communication is available only across gateway. Any migration strategy should allow teams to incrementally refactor the application into smaller services while still providing continuity of service to end users. Here's general approach. Stop adding functionality to the monolith. Divide the application into layers if it is not already divided. Decompose and decouple the monolith into a series of modules, later microservices. To help facilitate this decomposition, a viable software development approach is to apply the principles of domain-driven design and clean architecture solution as well. The approach can be applied retroactively to an existing application as a way to begin decomposing the application. That can be done in few steps. Identify the relevant model in monolithic application. Define the domain models of the monolithic application. The domain model is abstract model of business domain. Define bounded context for the models. A bounded context is boundary within domain where a particular domain model applies. Apply explicit boundaries with clearly defined models and responsibilities. The bounded context identified in last steps are candidate for refactoring into microservices. On this diagram, message broker is added to support asynchronous communication. There are mainly two categories of interaction between services when using a message broker. Communication can occur one-to-one or one-to-many. In this case of one-to-one, a service can either send an asynchronous request and expect a response later, or produce a one-way notification that is to be consumed by another module, later service. In one-to-many interactions, producers are set to publish a message to topic, while zero or more consumers subscribe to that topic. In that case, that a producing service expects an asynchronous response after publishing a message, the interaction is referred to as public async response. This diagram represents fully separated modules, and those modules are transformed into microservices. Now, those microservices are independent applications when it comes to business logic, and only one more state separates them from becoming fully standalone microservices. Keeping a shared central database is going to undermine the transfer to fully independent microservices, so the last step is to break it up. In this diagram on the slide, the final state is represented regarding data storage. Each service should have the freedom to determine its own approach to data storage and not to have to worry about what other services are accessing and changing it. This is all for my part. Now my colleague Zoran will tell you more about the business value of switching to microservices and some aspects of client relationships. Thank you.
So in the previous slides, we've shown the technical perspectives of a technical architectural redesign. But we must mention another aspect which could also be a source of challenges. My name is Zoran Vukosaviev. I'm working as a solution architect for HTEC Group. I have 20 plus years experience with multiple fields of industries such as healthcare, travel industries, or fintech. Imagine the situation that you have selected the best design ever. You have selected the best strategy for switching Monolith to microservices. You have also prepared a pitch to convince the stakeholders of the necessity of the architectural changes. The pitch sounds like the seamless refactor of this monolithic solution to microservices gives the opportunity to introduce state-of-the-art technologies. The most current components can improve the reliability alongside with better performance. The containerized approach also enhances the deployment. Wow, sounds impressive, sounds professional, and the answer is quick and simple most of the time. No way. You would ask why no way? Why the business people do not understand that need is important, the architecture is important. Unfortunately, the business people see the things a bit different. In that offer, they do not see any feature. No feature means no value. and no value will result, no way, because nobody will spend any money without a return of investment. Let me show what is the source of that miscommunication. The terms used in the original speech mean different for business people and the technical people. Let's see how a business folk looks the pitch. As you can see, the technical terms just faded out because business people do not speak that language. They mean nothing for them. The words seamless, refactor, and the state of the art are familiar but raises red flag immediately. The reliability and the performance are resonating better to their mindset, but they seem to be just a placeholder in this context. In order to break that barrier, I prepared you a dictionary for engineers and stakeholders. Seamless means user will not have any new feature. Refactor means we will replace the old bugs with new bugs. The state of the art means new toys for engineers. And as you can see, the reliability and the performance are just buzzwords in alone. I collected some sentences which helped me to convince stakeholders in my professional career. Let's see them one by one. We can reduce the monthly hosting cost from $50,000 to $5,000 by revising the system architecture. By spending 3 man-months of an innovation, we can decrease the release period from 3 months to a month. By implementing the technical feature, we can mitigate 70% of the reported defects, which save the time of 2 developers in a sprint. With automated scripts, the on-premises deployment can be achieved within 4 hours. Currently, it takes 5 weeks in average. The sentences could look similar than the original pitch speech, but let's take a closer look. The first sentence was, we can reduce the monthly hosting costs from $50,000 to $5,000 by revising the system architecture. You would say, hey, this is a buzzword. And yes, you're right. The cost reduction, if it would be sitting alone, is a buzzword. But combining with numbers and metrics, it turns to be an offer, which is understandable and clean for the businessman. If we check the second sentence, by spending 3 man-months of an innovation, we can decrease the release time, has the same values. We have the offer, we have the numbers, we have a relevant metric, the months, and that sentence is extended with a cost estimation, which also helps the stakeholders to make the proper decision. I would underline that selecting the good metrics is one of the key success factors. If we select dollars or other currencies, this is awesome. The time-like values like man-month or time reduction is also good because it's quite easy to convert to currencies. If we use very technical measures like number of CPU, the amount of RAM, T2 micro in AWS, it has less relevance for business people. We must convert them to dollars, euros, or any other currencies. Now we see how we can sell the idea with success. Let's see where we can find the business value of a refactoring. I identified 2 kinds of benefits, the direct and the indirect benefits. The direct benefits are those values which are really easy to monetize. For example, reducing an OPEX or CAPEX means we spend less money. But as I mentioned, the time saving is also easy to be converted because most of the stakeholders know the cost of a team and it's just a simple multiplication. The indirect benefits are the tricky ones. Even if a refactor gives more integration with other products or a better time to market, it has business value, but really hard to estimate it. The situation is the same with the quality improvements. Software mitigations, like can save company to pay up to 700 million GDPR fine for a company. But it's a theoretical benefit. So my recommendation is to spend time to identify these values, including the indirect benefits, and in collaboration with the product team, find the currency values of those assets. Our job will not end when we have the approval of the refactoring, and following the lean or the agile principles can keep the customer satisfaction at a decent level. You should think in iterations. As you will see, a refactoring could take years, and you cannot do everything in a single shot. So if we think in iterations, we can also introduce new features alongside with the refactoring, which also keeps the customer trust. If we have to deliver in multiple steps, the prioritization is also a key factor. We should focus on the biggest pain point first, because we can convince the customer that the investment is good. If we deliver the values in each iteration, and we can provide a transparent behavior, providing metrics and comparison with baselines, it also keeps the customer satisfaction high, and we could convince the customer that it's worth the money we spent. As an architect, you would see as a kind of schizophrenic role, because you must be aware of technical aspects of refactoring. You must be familiar with architectural designs, implementation strategy. You must know wide range of technologies, but you must be able to understand the business aspects of a change, including identifying the customer needs, finding those business values which are useful, define baseline values and KPIs, and you must be able to track those KPIs during the whole development. And in the last slide, I want to demonstrate that refactoring and convincing business folks is not an impossible mission, because it's not a unique action in a company's life. So most of the startups develop monolithic and simple application due to the time pressure, due to the short budget. But when the demands are growing and the complexity is increasing, that simplicity turns to be an obstacle which must be tackled. In this case, the companies start developing a more flexible and scalable application. As you can see, the Netflix or Spotify is a good example. As a result of my study, I have experienced that those companies who tackled that issue were able to create a flexible, scalable application with a new culture of development, which was beneficial for the developers and provided a better ecosystem for innovation and supported those companies to grow. Thank you for your attention. If you have any question, we are happy to answer in the upcoming Q&A session.
Hello, everyone.
Hello.
I guess you can hear me all. Okay,
Yes,
so obviously we are dealing with a very interesting topic today, very comprehensive one, I would say. And our presenters today, thank you very much. As you could see, both our speakers during the video presentation, Ilya and Zoran, were covering the same topic from two different angles, the technical one and the business viewpoint, the two viewpoints that are inherently different, very interesting. And today as a team, 4 of us will be available to try to answer some of your questions, maybe to try to offer you as much useful information as possible about the topic, to share some of our experiences. And Ilya and Zoran, we've seen them during the video presentation. Today with us is also Milan Dichanin, who's our division head of technology, who also participated and contributed to the presentation, and will also contribute with his knowledge and experience to try to address some of your questions. So you should feel free to ask the questions or to, join the discussion. Okay. I can see there's one question. Sounds interesting. So about the topic, when we deal with the transition from monolith to microservices, there's a certain risk of failure. And in your opinion, what are the most relevant factors that can have a biggest impact on whether final outcome will be success or failure?
So, okay. So from my perspective, I think we should start with defining what is the success. So what we use as a KPI. So a better performance, a cheaper hosting, better scalability, etc. So my advice is to start thinking the KPIs and start measuring a baseline and start tracking during the development, just to be able to prove it, that you're success or not.
Okay.
I think what I have experienced as a big failure when the enthusiasm evaporated during the transition. And we had a half done something, which is the worst scenario, I think.
Okay, thank you, Zoran. Actually, I do have my own opinion about this one. Generally speaking, I think that we all clearly understand that this kind of decision, first to make it, that might be a simple yes or no from the business perspective, but still it's not a lightweight decision. It can have a big impact on any client's business or so on. So I think that the first thing that really matters is for all the stakeholders, and when I say stakeholders, I mean the people that contribute to the decision making, so both the business and technical people. I think that and Ilya already mentioned that during the presentation, that all the stakeholders should share the common understanding about both monolith versus microservices, the story about pros and cons, and to clearly understand the benefits and promises of each one that we can get or lose. So that's the first thing, because I think that if we made a decision that is wrong, that's automatically failure. For example, parts of the legitimate decision might be to get the biggest promises of microservices, such as to get the long-term agility, the ability to do very frequent and quick changes, to be able to innovate, to expand. If that kind of client is interested, yeah, that might be. Also to significantly improve the level of throughput or scalability of our system, for example, several orders of magnitude for a business that is very successful and running. So that's the story about the decision. And additionally, I do think that there is one very important question that we should ask ourselves when dealing with this kind of transition. And that is a question that should be underestimated, namely the question whether we are ready for microservices. And what does it mean in practice? It means first, at least in my opinion, that do we have a microservices expertise? And that's a very important one, because if not, that could be very painful adventure and very difficult lessons to learn. That's one part of the story. And the other part of the story is, I would call that minimum operational readiness when dealing with microservices. It means a few things in practice. For example, it requires on-demand access to deployment environments. it requires the ability to create a new set of CI/CD pipelines that will enable us to independently build, test, and deploy executable services. And also it requires the ability to secure, debug, and monitor our distributed systems. So, and I think that good preparation is always at least half of a successful job done. And I think these are the matters that really matter when it comes whether the final outcome will be success or failure. Generally speaking, of course, accompanied with the fact that Zoran mentioned that we need to define KPIs, OKRs, and different kind of metrics to be able to evaluate whether it's a successful failure. Okay, there's another question. It says, how can we, quote it, sell the overhead of introducing microservices to the client?
Okay, let me take the ball. So sometimes it's not an overhead. So if you imagine that you have to fight with a legacy nightmare without ability of testing and progressing, if you rethink and start implementing a new microservice, it sometimes takes the same amount of time. But if it has an overhead, once we did that the new features had been implemented in the new microservice, so we developed value and we developed the framework and the foundation of the microservice architecture during a feature development. And we just transitioned the existing functionality to the new architecture, but we had something.
Thank you, Zoran. And I'd also like to add, again, get back to the previously, what was mentioned, that story that when selling any kind of promises and benefits, you need to clearly communicate with the client and to make sure that the client understands all the benefits that he can get. For example, one of the biggest promises of microservices is to get that long-term agility. So the ability to do frequent changes very quickly, to accelerate your software delivery, because for some businesses, it might be the crucial part, without alternative solution in reality, especially for highly successful businesses. Without introducing microservices, in some cases, it is not possible to scale enough to support your business, to support the acceleration and the pace of growth of that business. And that is always very justifiable and convincing argument to persuade and convince business people that it is justified to go that way. Okay, another question says, how big of a project must be for you to decide to go the microservice way? Or do you always start new projects as microservices?
So I think the answer of the second question or the second part is easy. No, we have to investigate always the expectation and the needs of the customer. So we do not select microservices always. So it's not a Swiss Army knife, which is good for everything. How big? That's a nice question. I think it's not the size of the project, but the requirements are leading us to the microservices. So if high availability, scalability comes to the picture, we easy to jump to the microservice alternatives, even if it's just 2 microservices or 3.
Yeah. I just wanted to add something for the second part of this question. Always is better to start with modular monolith, and then if there is a need for it, you can transfer it to the microservice architecture. start as simple as you can. That's my advice. And I completely agree with Zoran about the first part.
Yes, also I do. I have to say that by believing that microservices, by sounding fancy, modern, and almighty architecture that could solve all our problems, it's simply not true. You know, as any architecture type, there are pros and cons for each one. Maybe for this time, I think that the big, it's not a crucial parameter here, how big is a project. Maybe I'd like to share one of our experiences in the past with the audience, and to try to illustrate what was the main driver for us. I remember at the time we were dealing with a possible transition there was a huge monolith that at that point of time had been running for a very successful business for more than 15 years, I believe. And suddenly the big monolith system started showing signs of unreliability. First small signs, and then eventually it started breaking apart during the peak hours when the highest load in the system was involved. And after this case, and that was so painful and frustrating experience for the client, especially given that it was an extremely successful business. The client was ready to accept any kind of even radical architecture, so complete redesign. During the first discussion, we sort of suggested to go microservices way, 3 to 5 years of development, a very ambitious plan, you know, time consuming, everything. And the client was actually ready. However, what happened? Second pass, with the help of two very experienced architects who started really challenging the topic. And that time, second pass, we did a very meticulous and diligent analysis of the systems. And then we were able to understand many details. Bottom line, we managed to identify the real bottleneck in the system, which was essentially, in terms of the size of the overall system, less than 5% of the size of the system, but that was definitely bottleneck. We did a performance, both load and stress tests, and identified. And that was sort of a data processing pipeline, several steps that were originally designed as a serious chain of synchronous calls, each of them being IO blocking call. So you understand the point. The system was not originally designed to handle that kind of load, you know? So as a conclusion, we decided to apply in microservice vocabulary a strangled pattern to extract that small part of the functionality, to design refactoring into 3-4 microservices, not 3 to 5 years of development, but instead 4 to 6 months, if I recall well. And eventually we managed, yes, we introduced combination of Apache, Kafka, and Cassandra. And by the way, Cassandra, and that was a very good use case for Cassandra and Kafka. What we eventually managed to do, we improved the overall throughput and the scalability of the system by several orders of magnitude. So we were talking about tens of thousands or even hundreds of thousands better throughput. And the general conclusion from the client side at the time was that the system would be safe for another 10 plus years, given the current pace of growth. So the success of that action was so big that was actually, you know, beginning of very fruitful cooperation between the two parties. But the best thing that happened, that high level of trust was established after that. So you understand my point. That was a very meticulous and detailed analysis. We applied simplification on us. So it's not by the book approach, but sort of simplification and straight to the point. And amazing experience, I have to admit. Okay, there's another question, which says, what is the process followed by your company to develop the microservices-based application? Like every developer should know the whole process and all the necessary technologies, or individual developers should know a particular part of the things.
Okay, let me start. How do I start? So I think it's yes and no. It's the simple answer. The developers must know the processes of the development, including how we use a Git, how we do branching, how we do testing and deployment. The necessary technologies, I don't think so. So imagine that Spotify has 800 plus microservices in different technologies. So nobody will know dozens of microservice framework just because Spotify is using it. So I think the team members must know the technologies what the team is using. I would mention that please do not select too many technologies. Just a quick example. So the Atlassian flushed to the toilet with the development of 10 or 20 plus team just because they selected too many different technologies that they could not harmonize the development. So select just a couple of technologies for microservices. But answering the original question, know the processes, yes. Know the DevOps part and be familiar with the team technologies.
Yeah, thank you, Zoran. Maybe just to jump in and offer my 2 cents for this one. Generally speaking, when dealing with microservices, it's a well-known story about the domain-driven design, about bounded context, decoupled pieces of business capability. It makes sense to do that. Another interesting question is also, and we essentially what we need to is to split the work of the original assistants. So we want to create really as autonomous teams as possible. So no way that any developer should be aware of everything. You know, every team should be responsible for one or few microservices to be, to be aware of the general recipe, how we do microservices. That's the story about the expertise. Another interesting question is when splitting the system and dividing into microservices. The question is what services must or should be extracted and to what extent. So how granularly we'd like to see. I think that one good approach is to start with a simple approach. For example, to carefully choose first microservice that we would like to extract from the Monolith system. To give you a feeling, a good candidate might be a sort of authentication component, to wrap it up as a microservice and start using and to do on it. So why is it so important? Because a simpler beginning will give us a higher probability for a success than to build the expertise in case that we are lacking some. Then to get a higher level of self-confidence for the team is capable, and then gradually to tackle more complicated problems. That's another good practice that proved to be, at least for us in our company. There's another question. How would you solve chatty services that request each other's data frequently?
Can I try to answer it?
Sure.
Yeah, I know about a few techniques that you can achieve that chatty services. So you can use distributed transactions and Saga pattern. So you can use also outbox pattern, and you can use event sourcing. So I will not go into details about each of it. So you can Google it, but I know those three techniques.
And also my small contribution based on experience that I found sort of useful. In a scenario when we were dealing with that kind of scenario, we recognize that actually you understand that the microservices, in case of chatty services, it's out of process components frequently communicating. And from the performance viewpoint, out of process many components having a chatty communication is definitely not a convenient way to reduce latency and to get the performance boost in that manner. So we, for example, we decided a couple of times to apply counter technique by merging few microservices together again, because we realized that in a very chatty communication that from one perspective, it deserved to be a single responsibility. And internally, to wrap up that kind of communication as a hidden communication, very performant in-process communication, or introducing gRPC and some performant protocols. But generally speaking, if asynchronous message-driven event-based protocol is defined between the microservices, we should strive to completely avoid chatty services, because that is one of the good signs that we might have missed a part of design. And I would recommend revision of the design and maybe coming up with a better solution.
Because of that, monitoring is very important.
Always, and get back to that minimum operational readiness. You know, it is very difficult to achieve success with microservices without providing all that integration glue, especially story about elastic nature of cloud and DevOps culture, and to be really skillful in that manner. Otherwise, very tricky. Another question, let me see. One more thing. Could you share or tell us the technology list you're using or the best tech for developing the microservice-based application? This one is ubiquitous and always interesting. Any thoughts from you guys?
You can start the war with it.
One of those endless topics.
Yeah.
I think it turns to be a religious topic. So I see one common point without telling any technology is the containerization. So sooner or later you will touch the Docker, maybe Kubernetes for microservices. And it doesn't matter you're using C# or Java or Go or Python
or Node
or whatever.
Yeah.
So I think all languages and frameworks are good for microservices. I think it depends on the capability of the team sometimes. And I do not dare to mention any technology, because I just start the flame.
That is one of the good points, that you can choose technology based on your team knowledge for every microservice independently.
Yes, I would agree with this thought. I mean, generally speaking, there is no sacred technology that is so dominant over the other ones. You know, there are few, and not just parameters that would impact the choice of technology regarding microservices. There are a lot of things, as mentioned, for example, the people you can hire and the other business-related parameters. It's a never-ending story. Anyway, we should, I guess, respect all, or at least most of technologies that can serve the purpose. And there's no single one, definitely, in our world. Okay, another one related to the QA. How does quality assurance automation fit in with the microservices? Should each microservice have its own QA and domain team? If so, should they all have a common automation framework used for implementing test cases, or each QA team can have its own? Thanks. I believe this one is very interesting. Any thoughts from any practical experience from you guys? It would be nice also to have a very skillful QA lead experienced, especially in microservices world, to elaborate on this one.
Yeah.
Nevertheless, we'll try to give our best. So any thoughts?
Yes, from my experience in previous project I was working, we had a few microservices that we were managing, and we developed our own framework for testing for QAs. And we were testing just a few microservices that we were responsible for.
Okay, maybe as an addition, my piece of opinion in this, what is really important to understand that microservices way is all about splitting the work and make it as independent as possible. And I think for example, when discussing QA strategy, testing pyramid, and how to deal with all those things, one of the important things is to understand that microservices should be also tested independently. Because I think any belief or attempt to do sort of end-of-end testing in a microservices way, introducing a lot of them, it's automatically a nightmare. That's not a philosophy. That's absolutely anti-pattern to do that. So we should strive to find a way to use a framework or whatever we believe is appropriate for our system to do independent part of testing. So including contract testing, performance testing, everything. And of course, to try to reuse our tools as much possible, even despite the fact in a system when microservices are implemented using polyglot technologies. So even in practical example that we use Java, Python, .NET, I don't know, Node.js, whatever, but still to try to reuse that philosophy of independently test them all, because by using the same tools, we can achieve, for example, the ability to do performance tests of any kind of microservices when perceiving it as a black box. And that's one of the recipes that I found very useful,
Just two things came to my mind. The one is most of the time the microservices will have a front end, and usually it is a single project. So at least on the front end side, a single team will test all of the microservices and the chains of the code. Or if you select micro front ends for microservices, and in that case, you would separate the QA teams and focus on an individual part of the project. And I want to underline the importance of the contract testing, which could be weird, but very helpful. So imagine that you're providing a microservice with providing REST APIs, and you ask the consumer teams to develop the test cases in a way how they're using your API. And you will be execute their test cases. And your development will fail if their test cases fail. This is the only way you can avoid releasing an API change which breaks others JIT or others assets.
Thank you very much.
And need a lot of attention.
Yeah, that's true. I mean, QA part of the story is very important because it's about quality, right? So anyway, I believe that we are slowly running out of time. And I want to share that my pleasure about being here today and sharing thoughts, experience, and I'd like to thank first our presenters. So Ilya, Milan, Zoran, thank you very much for participating. I'd like also to thank the audience for a very interesting set of questions. It's a shame that we don't have another 2 days to discuss the details. Anyway, so I guess hopefully we managed to offer part of our experience and to initiate the interesting discussion. And then again, thanks everybody. And until the next thing, have a nice day.
Thank you. Bye.